The next topic is electric flux. What is meant by electric flux? It is defined as the number of electric lines of force passing through a given surface. The number of electric lines of force passing through a given surface is called electric flux. Suppose, consider these are the electric lines of force. Suppose, if we consider a surface like this, how many number of electric lines of force are passing normal to this surface? That is called as the electric flux. The number of electric lines of force passing through the given surface is called as electric flux. Mathematically, it can be expressed as pi is equal to E bar dot S bar. Pi is equal to E bar dot S bar. That is equal to ES into cos theta. ES into cos theta. Or you can write pi is equal to integral of E bar dot ds bar. Pi is equal to E bar dot ds bar. Electric flux is a scalar quantity. Electric flux is a scalar quantity. Its SI unit is Newton meter square per coulomb or voltmeter. Voltmeter. Electric flux is a scalar quantity and its SI unit is Newton meter square per coulomb or voltmeter. Here, electric flux can be expressed as pi is equal to E bar dot S bar, that is equal to ES into cos theta. What is meant by E? E is nothing but the electric field intensity. E is the electric field intensity and S is the area through which electric lines are passing. Here it is. S bar is called as the area vector. S bar is called as the area vector. The magnitude of this area vector gives the area of the given surface. Area of the given surface. The direction of area vector is taken normal to the given area. For example, I am taking this is the area. Its area is taken as S. But the area vector is taken normal to this area. It is represented by S bar. The magnitude of this area vector gives the area of this surface. Magnitude of S bar is equal to area of the given surface. So, area vector is always taken normal to the given surface. Now, what is meant by theta? Theta is the angle between the electric field vector and area vector. Theta is the angle between the electric vector and area vector. For example, now let us see, this is the electric field here. Suppose an area is taken in this direction like this. Here I am going to draw a vector normal to this area. This is taken as S bar. But here electric field vector is in this direction and S bar is taken in this direction. The angle between these two vectors is taken as theta, where theta is the angle between electric field vector and area vector. So pi is equal to E bar dot S bar, that is equal to ES into cos theta. Suppose if this area is normal to the electric field, then theta becomes 0. If this area is parallel to the electric field, then theta becomes 90. Theta becomes 90. So we can define the electric flux as the number of electric lines of force passing through a given surface is called electric flux. We can express electric flux with the symbol pi as pi is equal to E bar dot S bar, that is equal to ES into cos theta, or pi is equal to integral of E bar dot ds bar. It is a scalar quantity, its SI unit is Newton meter square per coulomb or voltmeter. Here E bar is electric field vector and S bar is area vector and theta is angle between the two vectors. Angle between the two vectors. Positive electric flux. What is meant by positive electric flux? Suppose consider a closed surface here and the electric lines of force are taken away from the surface like this, away from the surface, then this flux is taken as positive flux. Since suppose here I am taking a small area here like this and this is the direction of electric field at this point and the area vector at this point is taken as ds bar. Here the angle between E bar and ds bar is taken as 0. Theta is equal to 0. Let us consider a small area, that is ds bar. Here the ds bar and E bar both are taken as same direction. Theta is equal to 0. So we can write phi, flux through the small element d phi is equal to E bar dot ds bar. Now the total flux integral d phi is equal to integral of E bar dot ds bar. Now phi is equal to E ds cos 0. As cos 0 is equal to 1, you can write E into integral ds, that is equal to E into S. So here we can write phi is equal to E into S. So for the outward flux, that can be taken as positive. Outward flux that is taken as positive. Now negative flux. What is meant by negative flux? Negative flux. Suppose consider a closed surface like this and electric lines of force enters into this surface like this. Here electric lines of force are away from the surface. Here the electric lines of force are enters into the surface. Now here consider a small area here like this. So this is taken as ds and the area vector at this small element is taken here in this direction. In this direction. Okay. This is the direction of the electric field. This is direction of the area vector. Here this is E bar. Now this is ds bar. Both are in opposite direction. So here theta is equal to 180 degree. Area vector is always taken away from the surface, but electric field vector is opposite to area vector. So let us calculate the flux passing through the small element area ds bar as d phi. So I am taking the flux through the small element. Flux through the elemental area ds can be written as d phi is equal to E bar dot ds bar, or you can write integral d phi. Integral d phi is the flux through the entire area, total area. Therefore, you can write phi is equal to integral d phi, that is equal to integral E ds into cos 180. Here theta is equal to 180 degrees it is. Therefore, the total flux phi is equal to E into integral ds into cos 180 is minus 1. That is equal to what? Minus es. Therefore, we can write phi is equal to minus E into S. Here it is. Phi is equal to minus E into S. So, for the outward flux, the flux is taken as positive. Inward flux, the flux is taken as negative. Phi is equal to minus Es. So, this is about the positive flux and negative flux. The flux is away from the closed surface, that is taken as positive. The flux is into the closed surface, then the flux is taken as negative. Phi is equal to minus Es. Have a look.